Dimension. It can be defined as the measurement of something in a particular direction. So you've got a line or you've got a square. So it's something, an object. It's measurement in a particular direction, or we can say it's the minimum number of coordinates which are required to specify a point within it. You've got this line or say ray actually passing, and this is the x-axis, and I mark this red line on it. So we could measure this red line only by using the x-axis. If I mark this point, this point is one dimensional, 1D, and it could be understood by using one coordinate axis. Now you have 2D, something called as 2D, which requires two coordinate axes. So you've got this x-axis, y-axis, and this plane, and I've got this circle. This is drawn in this coordinate planes, and using these coordinate planes, these unit squares, I can understand the area of this circle. So now let us see three-dimensional. In this we'll have three coordinate axes. So x-axis, y-axis, and z-axis, these three together, these are all perpendicular to each other. Here if you see, this angle is not 90 degree, because when you try to project a 3D figure, suppose this figure is 3D and I'm projecting it in a 2D plane. So this screen is 2D. Therefore if you see, even these angles right over here, these are not really 90 degree in 2D. In 3D they are, but because there is nothing called as height in 2D, we are not able to exactly measure these angles as 90 degree, as perpendicular to all the coordinate axis. All the dimensions are perpendicular. We're not able to correctly represent it in this. So a 3D figure like this cuboid, you can see I could measure its dimensions just by using these three coordinate axes. Now let's see what area is. So area is the space occupied by a flat 2D surface, and to calculate the surface area of a 3D object, you add all its 2D surfaces. It is the measured in square units such as square centimeters, square feet, square inches, etc. So I have drawn the first plane here, and I draw the second plane. Okay, and then I draw the third plane, and opposite to all these I have got three more planes, so total of 6 planes, so 6 surfaces. And when I'm calculating the surface area, this whole surface area and the thing behind it, I am actually adding the areas of all of these surfaces, area of 1 plus area of 2 till the area of 6. I am adding that to get the surface area of the cuboid, which the area which I'm going to get will be in terms of square units. It is the sum of all the 2D figures. Number of these rectangles which were required to form this cuboid, and the area of each of the rectangle added will give me the area of the surface of the cuboid. If I have this rectangle, I divide it into these squares. This is how I'll measure its area. Okay, so let's see. So I have got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15 squares. So that means I have got 3 rows and 5 columns, which when I multiply, I assume that I can get the area of a rectangle. So area of rectangle equals to the area of 15 squares, which is equal to the number of rows into the number of columns into the area of one square, which is 1 unit square, which is equal to 3 into 5 into 1, which is equal to 3 into 5, which is 15 centimeters square. So we can say the area of the rectangle is equal to length into breadth. Now see, in case of a parallelogram like this one. So I drop this thing, which is the height of the parallelogram, and you may wonder how to exactly measure. Let me cut this part, this blue part, and I am going to mark this as A, the base of the blue part, the triangle, and this as B. And now let me see, when I paste it on this side, right, I've got a rectangle. So this is A and this is B. So you would see and this is the height. So the base is equal to A plus B and the height is equal to the same thing, H. I just rearranged the parts of the figure and I got a rectangle again. So we can say area of the parallelogram is equal to the base into height, that is BH. So now see, if I divide this into half, I cut this into half, I get two triangles, right? Two triangles. So I can say the area of the triangle is equal to half of the area of the parallelogram, which is half of base into height, or half into base into height, that is half BH. That is how we get the area of the triangle formula. So now I ask you a question. What is the area of an isosceles triangle inscribed in a semicircle of radius r units? Think about it. The answer is r square. And many of you will agree to me completely, because what we first think about when we think about this question is, if I have this semicircle, okay, and I draw a triangle, many of you would draw it this way, the isosceles triangle. So we have got these as the radius, so people will answer r square. They would forget that we need to multiply it by half and the actual result will be half r square. So the area of isosceles triangle in the isosceles triangle in the semicircle, inscribed in the semicircle, is not equal to r square, clearly from this example enough. But there is a special case in which it is equal. So when I have got a semicircle and I have my, this as my isosceles triangle, in that case it is equal. So let's visualize this graphically. So I have my triangle ABC, and now what I'm going to do is I'm going to move this point C along the arc of the semicircle. So do you think the area of triangle ABC in this case, in this case, is equal to when it is in this case? No, it's not. Clearly this is much larger, and this is the largest possible area of a triangle, and in this case it happens to be an isosceles triangle in case of a semicircle, because these two sides are equal. As I move it down, the area keeps on changing, so it's not always going to be same. So here the height is 1, the base is same, here height is 1, consider centimeter or 1 unit. So here's height is different, here it's different, here is 5, it's different in each case. So in this case, in this specific case, the area of the triangle ABC will be equal to half into base into height. So what is this case? When C, the point C, is the center of the arc, and A and B are the end points of the arc, or we can say the diameter. So is equal to half into, the diameter is nothing but r plus r, that is 2r. The height is also r, so it's going to be half into 2r into r. 2 and 2 get cancelled, which is equal to r square, only in this special case. By doing this visual graphical representation, what I mean to say is the right question to ask will be, what is the area of the largest triangle that can be inscribed in a semicircle of radius r units, the largest triangle, and then the answer will be r square.